Okay, so we've got two equations. Let's just call them, for argument's sake, let's call them equation A and equation B. And equation A and equation B, well, we could call this equation C, really. Equation A and equation B talk about the thicknesses, because the thickness may vary for a wedge of film, the thicknesses at which constructive and destructive interference occur. And I don't want to label one of these guys as constructive interference and one of them as destructive interference, because I don't want to mislead you. But these represent phases of half wavelength shifts or whole wavelength shifts. And depending on whether the light inverts or not off of one of the surfaces, one could be constructive and one could be destructive. And this equation here just is an explanation of how to find the wavelength of light wave within a substance with a known index of refraction, where you also know the wavelength in a vacuum. Okay? And the way that you would find the wavelength in a vacuum is by C equals lambda f, or lambda equals C over f, if you happen to know the frequency of the light that you're talking about, because the frequency doesn't change in all of this. The frequency remains constant, even though the wavelength may change based on the substance that the light is traveling through. Okay? And that's going to depend on the index of refraction.